Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. Today we will start our new chapter 13, that is about the biochemistry. I have already uploaded the introductory lecture of biochemistry, so go and please watch that video. In today's lecture we are discussing about the carbohydrates. Carbohydrate is one of the biomolecules that are present within the living organism and are of significant importance. So let's discuss the carbohydrates. What are carbohydrates? Carbohydrates, as defined simply, we can define them as the hydrates of the carbon, and the general formula for the carbohydrates is CxH2OY. So this general formula shows that in carbohydrates the ratio of hydrogen and oxygen will always be 2:1. For example, if we take the example of glucose, the formula for glucose is C6H12O6. Now, if you take the simplest ratio between the hydrogen and oxygen in the glucose, then first write the number of atoms for hydrogen and oxygen, and then just take the simplest ratio, then you may write it as 2:1. So here this 2 refer to hydrogen and 1 refers to oxygen. So in all the carbohydrates, the hydrogen and oxygen would be in the simplest ratio of 2:1. So therefore we are calling these carbohydrates as the hydrates of the carbon, because this same 2:1 ratio is present in the water molecule. This is that plants in the presence of sunlight convert carbon dioxide and water into glucose and oxygen. So this means that during the process of photosynthesis we are actually forming a carbohydrate. Glucose is a carbohydrate. Now this glucose is then converted into other form of carbohydrates by the plants. Plants usually convert this glucose into starch and the cellulose. So what is the starch? What is the purpose of starch? Glucose is converted into starch for storing energy. So starch is basically the stored form of energy that is made up of smaller units of glucose linked together with each other. So starch is basically the polymer of the glucose. Similarly, the cellulose is used for the formation of structural components of the plants. For example, this cellulose is present in the cell wall of the plants. So these starch and cellulose are also the carbohydrates. So carbohydrates are generally formed during the process of the photosynthesis in the plants. So how can you define the carbohydrates? The exact definition of the carbohydrate is that they are the monomers and the polymers of aldehydes and ketones that have numerous hydroxyl groups attached with them. Now, the single unit is called as the monomer, and if those units are attached to each other to form the larger compounds, then we will call them as the polymers. So how the polymers are formed? These polymers are formed from the repeating units. And what are those units called? Those units are called as the monomers. So carbohydrates are the monomers and polymers of what kind of substances? They may be aldehydes or they may be ketones. And along with this aldehyde and ketonic group, there is another group present in them, which is the hydroxyl group, and there are more than one hydroxyl group which are present in the carbohydrates generally. These are some of the simplest examples of the carbohydrates that occur in the nature. Now if you look at the first example, it is glucose. Now here you may see that this glucose has an aldehyde group and hydroxyl group as well. So how many hydroxyl group are present in the glucose? 1, 2, 3, 4 and 5. 5 hydroxyl groups are present. So According to definition, this glucose is a carbohydrate because it has an aldehyde and it has numerous hydroxyl group attached with it. Similarly, if you look at galactose, this galactose is another carbohydrate. It has an aldehyde group and it also has numerous hydroxyl group attached with the carbon atom. Now, how glucose and galactose differ from each other? If you look at carbon number 4 of the glucose and the galactose, then you may see here that there is the difference in the position of hydroxyl group at the carbon number 4. This difference in the position of hydroxyl group has resulted in the formation of a new compound. So in the glucose, OH at the carbon 4 is present at the right side. However, in the galactose, OH at the carbon 4 is present on the left side. So glucose and galactose differ only by the position of the hydroxyl group. Third example is that of fructose. Now this fructose is not an aldehyde, it is a ketone, because here this carbonyl group, as you may see here, is present between two carbon atoms, and it is a ketone and it also has numerous hydroxyl group attached with it, as you may see here. So it is also a carbohydrate because according to the definition, it has a ketonic group, it has numerous hydroxyl group attached with it. Now all these glucose, galactose and fructose, these are the monomers. These are not the polymers but are the monomers. They are the single unit. Now we will discuss them, that how the polymers are formed from these monomers in our upcoming slides. So for now, you just need to understand the definition of the carbohydrates. What is it? This definition says that carbohydrates are the monomers and polymers of aldehydes and ketones that have numerous hydroxyl group attached with the carbon atoms. Now let's move towards the next topic, that is how the carbohydrates are classified. Now carbohydrates are generally classified into three types: monosaccharides, oligosaccharides and polysaccharides. Now let's discuss these classes one by one. What are monosaccharides? Monosaccharides are called as the simplest carbohydrates or the simplest sugars. They cannot be hydrolyzed. We are discussing the properties of the monosaccharides. Hydrolysis. What is hydrolysis? Hydrolysis is basically the chemical breakdown of substances by the water. So in this process, usually a larger molecule is broken down into smaller molecules with the addition of the water. This process is called as hydrolysis. So lysis, by term lysis, we mean that we are. So what is hydrolysis? Hydrolysis means the chemical breakdown of substances by water. As the term suggests, lysis means breakdown. So it is the process in which the larger molecules are broken down into smaller molecules with the addition of the water. So these monosaccharides are the substances which cannot be hydrolyzed. This means that water cannot break them down into further smaller units. The general formula for all the monosaccharides is CH2ON, where N may be 3 to 6 carbon atoms. So this means that the monosaccharides are the compounds having carbon number ranging from 3 to 6. So for example, if we have a chemical substance having the carbon number 3, if we want to write the chemical formula of a monosaccharide having carbon number 3, then we may take the help of this general formula. Just put the value for N, C3H6O3. So with the help of general formula, I have derived a chemical formula for a monosaccharide having 3 carbon atoms. Similarly, if you want to write the chemical formula for a monosaccharide having 6 carbon atoms, then the chemical formula would be C6H12O6, which is the formula for the glucose. So, on the basis of the number of carbon atoms present in the monosaccharides, these monosaccharides may further be divided into different subclasses. Trioses. Trioses mean all those monosaccharides having 3 carbon atoms. Tetros means the word tetra means 4, so this means that these are the monosaccharides having 4 carbon atoms in them. Pentose are those monosaccharides having 5 carbon atoms in them. Similarly, hexose are those monosaccharides having. So what is hydrolysis? Hydrolysis means the chemical breakdown of substances by water. As the term suggests, lysis means breakdown. So it is the process in which the larger molecules are broken down into smaller molecules with the addition of the water. So these monosaccharides are the substances which cannot be hydrolyzed. This means that water cannot break them down into further smaller units. The general formula for all the monosaccharides is CH2ON, where N may be 3 to 6 carbon atoms. So this means that the monosaccharides are the compounds having carbon number ranging from 3 to 6. So for example, if we have a chemical substance having the carbon number 3, if we want to write the chemical formula of a monosaccharide having carbon number 3, then we may take the help of this general formula. Just put the value for N, C3H6O3. So with the help of general formula, I have derived a chemical formula for a monosaccharide having 3 carbon atoms. Similarly, if you want to write the chemical formula for a monosaccharide having 6 carbon atoms, then the chemical formula would be C6H12O6, which is the formula for the glucose. So, on the basis of the number of carbon atoms present in the monosaccharides, these monosaccharides may further be divided into different subclasses. Trioses. Trioses mean all those monosaccharides having 3 carbon atoms. Tetros means the word tetra means 4, so this means that these are the monosaccharides having 4 carbon atoms in them. Pentose are those monosaccharides having 5 carbon atoms in them. Similarly, hexose are those monosaccharides having 6 carbon atoms in them. So the most you may say the familiar examples of the hexose are glucose and the fructose. So first look at the open chain structure for the glucose. This is an open chain structure. We have read about the classification of these compounds on the basis of carbon skeleton. We have the open chain compound, closed chain compounds. So what were the open chain compounds? Those compounds in which the terminal carbons are not linked. So this carbon and this carbon here is the terminal carbon. Since these two carbons are not linked with each other, so therefore we are calling it as an open chain compound. So this is the structure for glucose. You may see here that we have an aldehyde group. How many carbon atoms do we have in glucose? 6 carbon. And we have also numerous hydroxyl group attached with carbon atoms in this glucose. And if we want to calculate the number of hydroxyl group attached on the glucose, we may calculate them as well: 1, 2, 3, 4 and 5. So this means that 5 hydroxyl groups are attached with the glucose. Now this glucose molecule may also be called as aldohexose. Aldo means that an aldehyde group is attached. Hexose means that it is a monosaccharide having 6 carbon atom. So this glucose is called as the aldohexose. This glucose may also be called as pentahydroxyaldehyde. What the penta prefix means, it means 5. So this means that 5 hydroxyl group are attached with this are present in this compound, and since this compound also contains aldehyde group, so we are calling it as a pentahydroxyaldehyde. Another example of this hexose sugar is the fructose. Now if you look at the number of carbon atom in the fructose, it is 6. Glucose and fructose have the same chemical formula, that is C6H12O6. They differ in the structural formula, so therefore they are isomers to each other. But since the structural formula is different, so therefore their somewhat properties are also different. So let's discuss about the structure of fructose. In the fructose, you have a ketonic group. Carbonyl group is present between 2 carbon atoms, and along with that group you also have hydroxyl groups. How many hydroxyl group? 1, 2, 3, 4 and 5 hydroxyl groups. So this fructose therefore may be called as ketohexose. Keto means ketonic group and hexose means a monosaccharide having 6 carbon atom. This fructose is also called as the pentahydroxy ketone. So on the basis of carbon atoms present in the monosaccharides, this is the general classification or the subclasses present in the monosaccharides. Now let's discuss further some more properties of the monosaccharides. The most important property of the monosaccharide is that they can rotate the plane of polarized light. So what is the plane polarized light? We know that light is a form of electromagnetic radiations, and in these electromagnetic radiations we have the electric as well as the magnetic field, and these electromagnetic radiations are oscillating or moving in all the planes. So here in the diagram you may see that this light is randomly oriented and it is moving in all the planes. But if we put a certain kind of polarizer filter in the path of that light, then what will happen, that the light emerging from this filter would be oscillating or moving only in one plane. So if those electromagnetic radiations are only moving in one plane, then we will call that light as the plane polarized light. Now there are certain substances which have the capability to rotate this plane polarized light when the light is thrown on those substances, and if we look at the behavior of the direction of that light, then we may see here that those substances will be able to rotate the plane polarized light. Now this plane polarized light may be rotated in the clockwise direction or may be rotated in the anti-clockwise direction. So what happens that whenever we put monosaccharides in the path of the plane polarized light, then these monosaccharides rotate that plane polarized light in the clockwise direction. So therefore these monosaccharides are also called as dextrorotatory or the dextrose sugar. So if you are asked that why these monosaccharides are called dextrose sugar, you will say because these monosaccharides rotate the plane polarized light in the clockwise direction. And we usually study the rotation or the angle of rotation of this plane polarized light by different substances with the help of an instrument which is called as polarimeter. So glucose, mannose and galactose, these three are the monosaccharides. All these substances are mainly the dextrose sugars. So monosaccharides, another property is that the monosaccharides are white crystalline solids. They exist in the form of crystals. They have a proper or orderly arrangements of the atoms and molecules in the crystal lattice. They are soluble in water. They have the sweet taste and they cannot be hydrolyzed, as we discussed before, that since they are the simplest carbohydrates, so they cannot be further broken down into smaller units. and they are reducing in nature because they have free aldehyde or free ketonic group. Then because of the presence of free aldehyde and free ketonic group, we may consider them as a reducing agent, or we may consider them substances that are reducing in nature.